Welcome everyone to today's panel discussion on the applications of data science and informatics. My name is Laurent Dujanvry. I'm the Assistant Dean of College Relations and Development here at the College of Chemistry at UC Berkeley. And it's my great pleasure to introduce today's talk. Today's talk is part of Berkeley Ecosystems, a new initiative where you can learn, explore, and connect with Berkeley faculty, alumni, students, and industry innovators on relevant topics. Now for a few logistical matters regarding today's discussion. Today's panel discussion will be recorded, as were all past events, and we invite you to explore the recordings of this year's ecosystem events at ecosystems.berkeley.edu. We are planning to field questions today towards the end of our discussion, so please use the Q&A function as opposed to the chat function to share any questions or thoughts with our panelists. And finally, directly following our event today, you'll receive a short survey. Please take a moment to provide us feedback on today's discussion and future topics. And now it is my great honor to introduce today's facilitator, Professor Teresa Head-Gordon. Teresa joined the faculty at UC Berkeley in 2001 and is a Chancellor's Professor of Chemistry, Bioengineering, and Chemical and Biomolecular Engineering, and also a faculty staff scientist at the Lawrence Berkeley National Lab. Teresa has been a recipient of an IBM Shared University Research Award and was a Schlumberger, excuse my pronunciation, fellow at Cambridge University. Teresa is a fellow of the American Chemical Society, American Institute for Medical and Biomolecular Engineering, and Resolve German Center of Excellence. Teresa's research interests are in computation and theory in the areas of chemistry, materials, and biophysics. Thank you, Teresa, for joining us to facilitate our panel discussion today, and also for agreeing to kick things off with a brief overview of the development of data and informatics as a field. Thank you.
Thank you very much, Lo. So what I thought we would do is to introduce our distinguished panel who are alumni of Berkeley. And what I was hoping they could tell us about is a little bit about themselves and how they got into data science. So let's begin with Dimitris. And we'll go in some order. Okay, so Dimitris.
Thank you, Teresa, and thank you, Lo, for inviting me to participate to this panel discussion. My name is Dimitris Agrafiotis. I joined Pfizer 2.5 months ago as a VP of Digital, where I'm responsible for the digital strategy and portfolio for Pfizer's worldwide research, development, and medical organization. I've been working in pharmaceutical R&D for about 30 years now, always on the interface of data science, software engineering, and IT. I won't bore the audience with details. Maybe you can find all of that information on LinkedIn. But briefly, as you can tell from my name and my accent, most likely, I was born and raised in Greece. I did my undergraduate in chemistry there. Got my PhD in theoretical organic chemistry at Imperial, and then came to Berkeley as a postdoc, working with Andy Streitweiser on the 7th floor of Latimer Hall. What pushed me to data science was, I think, my second postdoc at Harvard with Inijay Corey's group, where I worked on the interface on applications of AI to organic synthesis. And I got really deep into this in my second job at a biotech company called 3DP, where we worked on sort of mining very large combinatorial libraries. So I'll just keep it short. Thank you.
Thank you, Dimitris. And so let's go to Sol next.
Hi, good morning, good afternoon, good evening, depending on the time zone you're in. My name is Sol Rashidi. I'm the Chief Analytics Officer for Estee Lauder. I've only been here about 4.5 months now. Prior to that, I had a short stint at Merck, where I decided to become the Chief Data and Analytics Officer there because I decided, okay, we're in the middle of COVID. What better place to be than to deal with data and insights than the #1 vaccines company in the world? But prior to that, I was the Chief Data Officer at Sony Music, and that was a lot of fun. For those of you guys who love music, know the music industry, you know, over the past 16 years, the music industry has had 6 different operating models, and they have gone from 8 tracks to cassettes to CDs to Napster, illegal downloads, if you guys remember that, to iTunes and downloads, to Spotify and Apple Music. So that's been a really fun ride. But I would say the first start in this position, when the role of a CDO and data science, advanced analytics, and building enterprise data lakes really hit critical mass and scale, was my first gig at Royal Caribbean. it was cool because I left management consulting to join industry. And I always say that I left selling the dog food to now eating my own dog food. So actually taking accountability for a lot of the strategies that I put in place for companies. So quite a pivot, quite a change. But prior to that, I was a chemistry major at Berkeley. And I played NCAA water polo for the team, and I played rugby with the men's national team. If you guys recall, Cal Berkeley had the #1 men's rugby team. So we used to play up in their field all the time. Still visit Berkeley, even though I don't live on the West Coast anymore. Happy to be here and happy to contribute back to my alma mater. Thank you.
Thank you, Saul. And Kevin, tell us about your background.
Yeah, certainly. And first off, just thanks. Really appreciate the College of Chemistry for the invite, for the organizers of the event, and for Teresa for moderating the discussion today. Myself, I actually had my PhD in chemical engineering from UC Berkeley, graduated in 2013 under the professorship of Ji-Wei Chu. And at that time, we were really starting to see the intersection of machine learning, data science, classical biology concepts, and protein dynamics. And so I got into the subject mostly because that was the new emerging techniques to glean insights out of data. And we are starting to see just the influx of huge cheminformatics databases from the protein data bank, large molecular simulations that could generate petabytes of data. And then the real, how do you inform that with true in silico experiments and in vivo measurements as well? And so it came into that mostly from the standpoint of what are the forefronts in theory and methods of machine learning? How do those have analogs in what you think of from quantum mechanics and from molecular simulation? And can we produce insights into biology that can ultimately impact human health or renewable energy? And really we're seeing the fruits of that labor here many years later, how this field has just exploded and how the accessibility to data science has become almost part and parcel of every research endeavor from groups across the country and across the world. So really an exciting time to be involved with health technology and genetics and data science.
Thank you so much. So what I wanted to do before we get started today in our conversation is to talk a little bit about how we got here. And so you could advance to the next slide. So, I'm a computational chemist, and for a long time, I worked on physical models, just like Kevin did, in regards to modeling molecular things like drugs or proteins, materials, et cetera. And all of that was enabled by what we call now, what we sort of didn't quite realize at the time that we were in, which was the golden age of computing. And that sort of began with Gordon Moore's observation in a rather obscure journal back in 1965 that the technology for transistor density was doubling roughly every 18 months. And what that meant was that compute capacity was increasing so rapidly, and that this this observation held true up until around 2015. Where we could see that the outcome of that computing revolution had massive economic and social impact, right? And the things that we now take for granted of desktop computing and cell phones, that power of a cell phone was what I was using during my PhD. And so what you can do with computing, where you're using sort of massive computational resources, is to do what we call von Neumann computing. That's the idea that there's a physical model with well-defined equations. They may be difficult to solve, but they're well-defined in regards computational infrastructure involving binary instructions. All right, so then fast forward, here we are, and we're actually in a new revolution if we go to the next slide, where we can now start talking about the golden age of data. And just the observation of the fact that we are being inundated with data, which is that in 2016, which is only roughly 5 years ago, 90% of the world's data at that time had been created in the preceding 2 years. And that's actually that's true today, which is that we are seeing, just much like we saw in the computing age, the age of data, which is that we are generating data at a phenomenal rate. And that phenomenal rate means that our ability to store it, our ability to query it, all of those things are rapidly advancing. And in fact, I think it's sort of an amusing fact is, we think about, millionth or a thousandth or units of billion, these things that are now starting to have new prefixes. Prefixes, for example, of where we're at in digital data storage capabilities is in the zeta prefix. And we got pretty much what's left now, the Yoda. And we may have to start developing new prefixes as the data starts to become much larger, okay? So, so continuing on here, if we can go to the next slide. What I wanted to then say is that, what do we do with that data has developed over time. And of course, one of the outcomes, what was originally driving what we call non-von Neumann computing, the idea that there's a mapping, there's an equation that you can't really write down that connects, let's say, some input representation into some output. And an example of that would be that, could I just take some data like handwriting of zip codes and actually be able to predict anybody's handwriting and putting down a zip code through some kind of recognition? Okay, so now how do we do this ourselves, which is that, we have a visual cortex that's able to sort of read off those 5 numbers and to be able to then, let's say, sort through them and make sure that mail arrives at the right destination. But of course, you would like to automate this. And this was a task that, was confronted by some of the early researchers at Bell Laboratories, which is where the transistor was actually discovered, and where some of the early greats in what was at the time called artificial intelligence. And that artificial intelligence, again, was to be able to, for example, do handwriting recognition, voice recognition, which is really important to AT&T Bell Labs. And what I'm showing here is what are quite simple equations, okay? Simple equations of taking some input representation and processing it through a model, okay, which I'm showing on the right, of the visual cortex, which is a neuronal structure, okay? And that neuronal structure is followed by a technique called feed-forward backpropagation. So of course, if you think, well, how well can you do in that kind of computing? And of course, I could just randomly guess what the numbers are, and I would be right about 10% of the time. And then I could essentially maybe analyze the pixel image and look at sort of where the dark spots are and where the light spots are. And that kind of model, I might be able to get this right about 22% of the time. But it was an incredible breakthrough to be able to do this through a artificial neural network that reached about 95 to 96% of accuracy. Now that's pretty impressive jump, but at the same time, 5% error is probably not good enough if we actually want to use this kind of computing for things like image recognition. And if we go to the next slide, this is where, the data science technologies really got better. And so when I was a postdoc at Bell Labs, I worked with some of the greats in machine learning. Jan LeCun was one of those, and he developed a technique called convolutional neural networks. And what this did was to now really be able to understand spatio-temporal structure, which again had an AI motivation through the visual cortex, to be able to recognize images and to classify them. And so what I'm showing here on the left are the fact that there's a database now of ImageNet, which contains about 15 million labeled images, okay? And from that, as we move from handwriting to image recognition, what we're seeing on the right is just really kind of a cartoon, a little GIF that's saying that given some image, can I classify it into its correct category? has reached a level of sophistication where, for example, with a convolutional neural network, you're close to 100% accuracy, okay, in recognizing those 5 digits. And as I said, which is now we're able to, with these more advanced machine learning algorithms, to do image classification of much greater complexity, and to even can create new images that actually could be false representations. And so what comes with this data science technology is that the technologies always get better, and they always are going to be used for the good, but they can also be used for nefarious reasons. And that's what we're going to talk a little bit today in our discussion. But let's continue on to the next slide to say, why is it a big deal? Well, as I said, which is that we all get into this business in science and engineering is because we want to make the world a better place. And we all know that we've been fighting this battle against coronavirus now for over a year. And we have wonderful vaccines that have been developed at the pharmaceutical companies, where our panelists are essentially, on those front lines doing that. But at some point, if someone is going to get COVID, then what we need are perhaps some therapeutics to deal with the actual disease consequences themselves. And so, for example, my group has been working with people in San Diego at Scripps to try to develop new drugs. And what we're using are data and machine learning technologies in order to do that. So I think that's just sort of one example of a big deal, but we're going to hear a lot from our panelists today about why is this a big deal. And so if we go to the next slide, what I really want to hear from Demetris and Saul and from Kevin is that obviously data analytics has exploded. It's come already a long way in how data analytics techniques are being used in machine learning and in artificial intelligence. But really what I'd like to hear from the panel is, why do you think it's a big deal? And where do you think we're going? Let's begin with Kevin.
Yeah, I see the biggest evolution from when I first started in the field back 2000, 2005 to where we are today is just how the tooling has become so democratized. You had to be almost an expert in IT, you had to be an expert in software engineering and machine learning and equations and theory, and you had to be an expert in biology. And that was just such a heavy lift. What we have today is these huge and great frameworks, platforms as service companies that can provide all of that. For example, at Myriad Genetics, where I lead our technology organization, we have to manage terabytes of sequencing data every day. And there's great frameworks that are cloud hosted, like DNA Nexus for doing secondary analysis of sequencing data. You have frameworks like Snowflake and Looker that allow you to do large scale, petabyte scale computations and data science. You also have machine learning frameworks and Spark frameworks that things like Databricks can give you. And that's if you're an expert practitioner. If you want to even go down to the most basic levels, you have tools like AWS SageMaker, where you just want to do that cat versus dog classification example that you had. That's almost button clicks away. That's a 5-minute exercise, when before it was almost a PhD to be able to do that. So I think that's been the greatest advance we've seen, is democratization in the tools, the capabilities. Now we're able to reap the benefits of that in all the applications, from security to healthcare to technology, to just improve the human condition with that as it spreads to being just part and parcel of just the tool chain everyone uses to do technology today.
Yes, actually, I just wanted to say that students here at Berkeley really want to get into machine learning and data science fast. And those types of that democratization makes that possible. So I just wanted to kind of echo that I agree with that. Demetris, do you have any insight here?
Sure. I would agree with Kevin on everything. Actually, all these things that we mentioned, data science, AI, machine learning, what's important to remember is that they've been used for decades in pharmaceutical R&D, at least. As I mentioned in my introduction, my first exposure to AI was as a postdoc 30 years ago. And in fact, that project, LASA, had a very long history, long before my arrival. So what has really changed today is scale, just the amount of data and the computational power that we have available today. I would say that when it comes to the learning algorithms themselves, the progress has been more incremental. The underlying methodologies haven't really changed all that much, but if you combine this incremental improvements in methodology and this extraordinary amounts of data and practically near infinite compute power, you can do things that you never thought possible 10 or 20 years ago. And Teresa, something else has changed as well. I think today, the vast majority of the data is generated through continuous monitoring. With our mobile phones, sensors, satellites, cameras, microphones, online activity, you name it. And much of this monitoring is done on consumers, people, ourselves. So we're being constantly tracked, and that has implications. I'll stop here.
Well, thank you, Demetrius. I just wanted to say that I guess, working at a university where we're kind of dealing on the fundamental side, we see sort of enormous growth in the last 5 years in regards to the technology, the underlying machine learning algorithms. And so maybe there's this sort of translational time that takes, before it actually sort of reaches practical, outcomes. So that'll be interesting. Maybe we can talk about that later. And so Saul, I remember talking to you and you said, you didn't find data science found you. And so can you tell us about that?
Yeah, I don't think anyone ever grows up and says, this is what I want to do, or this is what I want to be when I grow up. You hear, oh, I want to be a doctor, I want to be an astronaut, I want to be the president. You don't say, hey, I want to have deep subject matter expertise in data. Like, that's just not something that was ever even an option. And not to age myself, but I am in my 40s. And back when I was doing my undergrad and my grad, degrees in information management systems or computer science, like those just weren't available. So it wasn't a career path that wasn't even an option. And I sometimes say it chooses you, you don't choose it, but you either gravitate towards it or you accidentally fell into it, because it does require dexterity and just different skill sets. And I always say that I started off as taking the job that no one wanted after I was playing sports. And I was like, okay, what can I lean in on? Because I know I don't want to do chemistry. I don't like being in the back office all day long. So what can I do that can sort of leverage some of the other talents or strengths that I have? And, I took the job that no one wanted. It was to become a data engineer. And back then, the only things we had was Excel spreadsheets and pivot tables. And it's funny because 20 plus years later, it's still predominantly what we use is Excel spreadsheets and pivot tables, even with all the fancy tools. When you break it down, that's how most Fortune 100 companies operate. PowerPoint and Excel spreadsheets. I hate to say it. But one thing led to another, and I found out that there was tremendous opportunity here. Whether people realize the value of data 5 years ago, 10 years ago, 20 years ago, they definitely do now. So us geeks that were sitting in the cubicles and sort of in the back office, losing ourselves in data analysis, we're sort of having our moment in time right now. And it's really cool to see, because the number of graduates that are coming out of the programs, the number of recruits, the number of internships, the number of talent that's just available now that wasn't available then is just vast. And it's really cool to see this space grow.
Oh, actually, that's great. And so I'm just curious, Saul, what kind of background do you like to see in the new people you're hiring? Do you know what I mean? Like, do you train them on data science, or do you kind of have some expectation now that they come in a bit trained already?
It's a really good question. I think I've managed a few different types of teams. I have managed teams that have been trained. They know machine learning components and techniques. They know neural networks, very scientific, very heavy degrees in engineering, applied mathematics. That has its strengths and its limitations, because when it comes time to work with the business, when it comes time to translating the so what into the business value, when it comes time to asking for funding because this was the business value that we were able to create, I find sometimes at teams like that are purely focused on hardcore trained graduate PhD types of individuals, it's very difficult to explain the business value that we're producing, because they're more interested in the models and techniques that are going to give us the outputs that we need. The translation just doesn't take place. So, and then I've also led teams where they've had an analytical background, so they know their SQL scripts, or some of them know R, and it's fine, but they've got business knowledge, and because they've sat within the business and as a side gig or as a side project, they've just gravitated towards the analysis. What ends up happening is we have great relationships with the business, but we can't get past a certain point. So if we want to develop prediction models around retail profitability, or if we want to build recommendations engines to increase conversions in an e-commerce basket, we've got to outsource that work because they haven't necessarily been trained. So the teams that I'm starting to develop now are those that have been classically trained in applied mathematics, MIS, computer science, data engineering, combined with, and what I call it two in the box or a shadow methodology, with those that have been in the business, so that the two can translate each other's works into something meaningful for the business moving forward. Because I think the art of storytelling can't be skipped. I think the narrative can't be skipped. And I think always keeping the team at hand, focused on what it is the work is and not losing ourselves in the research in corporate America is very, very important. And so figuring out the balance is difficult.
All right. Well, that's very instructional for an academic, I have to say, as I've trained, well, thank you. And so what I wanted to talk about next a little bit are maybe sort of given the time, I wanted to jump to diversity and ethics in regards to data science, machine learning, et cetera. And I teach ethics here at UC Berkeley, and that's been data. There's always been ethical issues around information technology, things like privacy. Do you see anything new on the horizon, or a new form of sort of ethical conflict that's arising in regards to just the emergence of lots of data, or the way that we're using data and data analytics and algorithms in ways that's going to cause the public to get worried? And so let's begin with, let's say, Dimitris.
That's a great question, Teresa. I think there's actually multiple questions into this. If you look at ethical uses, I think I believe you mentioned in the beginning. To me, the possibility of distorting reality is the greatest concern. My greatest concern in this business is the deep fakes. I'm terrified of them, actually. The ability that you can create video streams, images, text that is virtually indistinguishable from the real thing. It's terrifying because it can become a tool for massive manipulation and distortion of our reality. And honestly, I cannot predict what the future has in store for us, to be honest. When it comes to the ethical use of the data, particularly in my industry, it has many, and diversity specifically, which is what you asked about, that has many different dimensions, Teresa. I'm proud to work for an incredibly ethical company, and we try to apply these principles of diversity and ethics in everything, in our inclusion, in our workforce, in our clinical trials, and in our partnerships and our supplier relationships. When it comes, let's focus on clinical trials themselves. We need to make sure that underrepresented communities are represented more equitably in these clinical trials, because the results depend on them. For instance, we have committed to achieving, racially and ethically diverse participation at or above the US census or disease prevalence levels, if they're applicable, in all of our trials. And today, 65% of all phase 2 and phase 3 study starts in trials that we start in 2019 and beyond. We're tracking diversity, and we're introducing this in our training programs. In fact, we even share information now. There was a paper just last month, I believe, at the end of April, that came out of Pfizer. We published, our clinical trial diversity, covering race, ethnicity, sex, age, at least in the US. That was the first step for all the studies that we ran from 2011 to 2020, I believe. I'm not sure if I'm answering your question directly, or that's what you had in mind.
No, that is actually what I had in mind. I was wondering, these are kind of, like you said, old ethical questions. Kevin, I know that we had talked at one point about the fact that that the use of data, for example, like face recognition, right, is can be that people of color are actually not as those algorithms are failing, for example, on certain classes of system because they've been, the models have been trained on specific classes of people, and so that's an example. But also, like in Demetris's case, in your case, Kevin, where making sure that women and people of color get access to the sort of the same benefits of drug trials. And I was just kind of asking, and maybe Kevin, you could pick up off of Demetris. Is there anything special about data analytics that's raising new questions in that area?
Yeah, and it's especially a huge problem in genetics as well, because of just a lot of the bolus of information that's been generated over the years has been generated for primarily Northern European ethnicities. So an example that we have is that at Myriad Genetics, we have a product that predicts the risk of breast cancer. And there's a way to do that. And we do that for hundreds of thousands of women every year. And the classic way of doing that is looking for genes like BRCA1 and 2 that lead to breast cancer. And that's a well-studied, well-proven technique. But the more data science approach is if I look over a cohort of hundreds of thousands of women and I see what markers across the genome are slightly enriched in those with cancer and which ones are slightly protected in those without cancer, I could actually produce a risk model for breast cancer. And that's a product we were able to launch, but it only was validated in Caucasian women because we didn't have enough discovery, we didn't have enough data. And so it took a very concerted effort on our part to go out there to underserved ethnicities, collect samples, do rigorous validations. And it did take us 2 years, and we're just this summer launching a all ancestry risk model, which is just predictive and powerful in elucidating health understanding and illuminating the best pathway to proper health outcomes. But it has to be a concerted effort. You have to value the data, not because it was easy or expedient. You have to go out there and acquire that because it is just ethically and responsible, the way to bring the most amount of benefit and not marginalize some classes of citizens only because they weren't part of a larger consortium study earlier in history.
Mm-hmm.
But it is a focus, and I think it does have to be part and parcel with not just the predictive models, the insights that data and analytics gives you, but the validation, the quality control check on you, both from an accuracy perspective, from a reproducibility, from a longitudinal accuracy, but also these bioethical constraints. Does our data have unbiased sampling? Does it represent our community effectively? And does it not introduce different prejudices in the community and just insert those into a mathematical model where they're almost more nefarious and how you can't notice them?
Yeah. That's very interesting. And one of the kind of the sort of the getting back to a little bit more the kind of the technical question maybe of how do we sustain this? In other words, Kevin, you had to go out and do get that data in order to deal with the diversity. But how do you sustain this? In other words, how are we going to sustain this big data effort? And so maybe we can turn to Saul and maybe if you can sort of tell us about how are we going to sustain this into the future? So Saul, you're muted. Let's say, yeah, there you go. Oh, nope.
Yeah, I think it's program control. There we go. I was going to say, if anyone has the answer, I'm game to listen. For me, it's interesting. I don't know, maybe it's an overly simplistic approach, but the qualities that I'll look for in a candidate when building a team, the first two are hustle and aptitude, and that comes in all forms. While the pool of resources is skewed, it's interesting. What I found is that when you're writing a job description, the way you write the job description can actually re-skew your pool of candidates. Let me give you an example. Earlier on, we wrote an AI algorithm that took a look at all the JDs that were being responded to across the various different roles within the data and analytics space, from data engineers, to data modelers, to data scientists, et cetera. And we were trying to look at the probability and the propensity of which ones had a more balanced pipeline of candidates and which ones didn't. And we wrote an algorithm to kind of comb through. And it was interesting to see very clearly that the ones that didn't have a balanced pipeline used very specific words like lead, like run, like oversee. And the ones that did have a balanced pool were using more words like collaborate, partner with. And so what's funny is when we go to market, I haven't found a shortage in diversity and inclusion candidates. A lot of it comes down to how the job is posted, how it's worded, and the network that we get to tap into. Yes, I would say that. Is there a skew in pipeline? Of course. But I think when you have a network that's vast, when you're tapped into the different programs, for me, it's become much, much easier to balance that discussion within my team. And when I always word things as partner, collaboration, co-lead, whatever it may be, and my first two skill sets are like for hustle and aptitude, diversity on my teams has never really been an issue. There's a lot of people out there. You just have to find out how to reach them. And more often than not, I think there are individuals who lean into the opportunities versus those that say that, well, maybe I'm not 100% qualified, so therefore I shouldn't. I think oftentimes that's what holds people back, not necessarily the talent pool. So in short, growing up, I never really looked at that. Of course, I worked with predominantly mostly male colleagues and male partners and male teams. But I think since 2016, I've noticed a huge pivot. I think it comes down to how you position and how big and vast your network is. There's a lot of great talent out there.
All right. So one way,
it's not a good answer.
No, that's a good answer. I was just going to say that's going to be one way that we sustain is to sort of make sure that we increase the talent pool. And so, so those are good ways to make sure that that talent pool is diverse. You know, one of the ways that I was thinking about sustainability too is just sort of, you know, where are we going to store the data? How do we query the data that we're generating in new ways? And so one of the examples, you know, when we were, you know, developing large trajectory data and trying to look at correlations with, let's say, binding affinities of drugs to, you know, spike protein, for example, we actually got in touch with the Brain Initiative because they think about connectivity, you know, in ways and connections in data that, you know, they're trying to think more generically about. And so that's a kind of a question that I have for Kevin, let's say, you know, in regards to, you know, how do we sustain this data revolution? You know, like what are we going to do with data besides store it? Okay.
Yeah. Now, there is a very nice race between those who create more sophisticated algorithms to those that produce the architectures and the hardwares that can implement them. And I just know for ourselves, we have probably two challenges, one of which is we always are constantly trying to get the highest accuracy in sequencing results. And for very complicated variants to get that high degree of accuracy, sometimes we've employed very sophisticated deep learning models that look upon, you know, millions of different pieces of data sets that look at really complicated LSTM models and have to be trained on not only just GPUs, but actually tensor processing units that you can get from Google Cloud Platform. And so there is a technical superiority race of just the sophistication in the algorithm to solve these highest degrees of accuracy with how do you actually be able to do that on a, you know, human reasonable time scale. Mm-hmm. But I think the more interesting development that isn't just pure technology brute force is how do you think of access to data? I think one of our biggest challenges is being able to share data, have data exchange, have homogeneity in how you structure it and normalize it. And I think there's a lot that can be done in these data federation models where not everyone has to have a copy of petabytes of data in all these different locations, but how can you query each other's data, but do that also in an ethically responsible way? So I don't compromise health protected information, or I don't de-anonymize the data. And so there's some really nice frameworks. There's some nice theory and methods for how you can quickly and efficiently access data, but do it in a bigger, more collaborative environment. And I think that's something we see a lot, either facilitated through the NIH and their sponsored programs, is almost making health data brokerage and health data exchange a key component in those studies that are publicly sponsored and facilitated.
You know, that's interesting also, but at the same time, you know, companies have to make money. And so therefore, how do you guys sort of protect data in regards to IP? And Dimitris, you've been thinking about that, I'm sure, for a long time. So.
Can I elaborate a little bit, add on top of Kevin's comments?
Sure.
I suspected your question, Teresa, had to do with how do we deal with just the increase of the volume of data? Where do you manage, where you store it? First of all, there is such a thing as throwing it away when it's no longer valuable or it's obsolete. But I interpreted your question. I gave it a different interpretation as well, because all of this computer power has enormous toll on our planet. It's not electrons, they keep working because there's a lot of power that goes into them. And you look at the latest fad, the blockchain, bitcoins, and cryptocurrencies, and NFTs, and all that stuff, and it's literally an environmental disaster in the making. So I think we need to make, having said that, technology is the solution. Advancing technology is the solution to many of these problems. But to come back to your question to me specifically, one of the issues we're struggling with is making sure that we manage the life cycle of the data in its entirety, from generation until its archival and or at some point deletion. We will be reaching a point, Teresa, depending on the experiment, where the collection, it'll be a lot easier to just regenerate the data on the fly than it is to store it and retrieve it. Now, not in all cases, obviously, but there will be a lot of cases where it's just easier to do this. So we really need to solve this problem of environmental sustainability. This very, just to make a little comment here, this very video conferencing that we're having today, do you know how much carbon it emits to the atmosphere? It's estimated that about, I believe, 1 hour of video conferencing, depending on the number of participants, can generate up to 1 kilogram of CO2.
Yeah.
It requires about 10 liters of water.
Just like you mentioned, Bitcoin mining, is actually eats up, is a big CO2 emitter, believe it or not. Yeah.
The entire country of Argentina, I think, is equal to the Bitcoin energy demand.
Yeah. Well, listen, thank you so much. I think this was a good way to get us started, because I'm sure that the audience has got some questions. And so I thought we should try to maybe, so Saul, I think you got a question here, which is, what does it mean to increase the pool of candidates on a more tactical level? In other words, an example of initial and following steps, how could you illustrate that for us?
Yeah, so it's a little bit more grassroots. I think, typically when you're building a team from scratch, or you've inherited a team and you have to restructure, it doesn't matter. If you're trying to hire for talent, the classic way of doing it within organizations is you create a job rec, it gets approved by HR, they post it on their website, and then they kind of wait until candidates apply. Well, you can kind of understand how that's difficult, because for those of us who are looking for jobs, the last thing you want to do is go through every single website of every single company and see if there are data science positions, information management positions, data engineer positions. That's just not reasonable. So the other path is, okay, there's different websites that do that for you. But again, the onus is really on the individual to look for the jobs. What I've actually found and discovered is there are a lot of leaders who are active, engaged on LinkedIn. And so I'm actually taking a very different approach in that I'll post a position on LinkedIn. The candidates will apply to me directly, or maybe to a lead or a delegate of mine that I put in charge, to see if we can actually open up the pool of candidates that apply. And I get typically a very diverse set of resumes. And it's not all skewed towards one gender or one ethnicity. It's extremely diverse pool. And that's actually worked out a lot. It's more work on our end to tap into our network, to tap into peers that we know where headcount is frozen, but they've met some great candidates, to actually actively pursue something on LinkedIn. But what you end up getting is a stronger pipeline of candidates who fit the bill. And even if there wasn't a position you posted, sometimes you get resumes, you're like, it's not exactly what I need, but it sounds really interesting because there may be something opening up in 2 to 3 months. And so when I say tactical, it means that if we put in the effort and reach out to our network and some of the social sites, they're there. it's there for sure.
Okay, thank you so much. So I'm going to turn to a different question. This is actually going to involve all of you, which is that, you know, what could you give a specific example of what you're working on now, and why is it exciting? But at the same time, why is it also frustrating? In other words, you know, that's how everything that's tough to work on works, right? It's the excitement is what allows you to deal with the frustration. But we would love to hear examples in your own. In your own organization about that topic. So let's start with maybe Kevin.
Yeah, certainly. So yeah, a little bit of a different theme, which is a major area that we focus in our technology group as well, is not only on the science that powers the test, but on the access of the tests as well. The reason is for, you know, even for breast cancer, of the people out there in the US who should be screened, to date, only 5% have. So you have 95% of the population who qualifies for breast cancer screening because they've had a family history, they're at risk, but it's really hard to reach those people. And it's hard for many reasons. There's the barriers of healthcare, there's the barrier of access and cost. And so we do a lot to reach them directly. And data science powers that, which is what are the online channels, what's the content strategy, what's the customer conversion, how do you facilitate the different interactions? And so bunch of our analytics is almost looks like ad tech analytics, which is how do I target the right message to the right person at the right time to get them to convert with this possibly life-saving technology. The challenge is you're still working within the classical US healthcare system. You have the burdens of the unpredictability of what a person's out-of-pocket expense will be for this test. For some, it's covered and it's almost free. For others, it can be quite expensive if they're on a high deductible healthcare plan. And so you can be very sophisticated in your modeling and, you know, throw XGBoost at it all day long to come up with these very highly accurate models, but you're essentially reverse engineering what is still to a certain degree a problematic healthcare system in the US. And so that's probably the thing we balance with a lot, is how much you can be fancy with your techniques, but are still tormented by the most banal problems of, at some point I get a blood sample from someone, how am I going to find them a place to draw the blood that's contracted with us? Right. So that's sort of some of the balances we challenge with.
Thank you. That's very, the healthcare system, that's another topic. Demetrius.
Well, I can tell you, I can give you the easy answer to this, Teresa. what I'm working on is just getting to learn Pfizer, which is a vast place. You know, we do data science in so many areas. It's employed in so many areas, from early discovery to, you know, for routine molecular property prediction, you know, SAR model building, structure activity relationships, to how the drug candidates, you know, the chemical structure is correlated to biological activity, phenotypic screening, you know, RNA sequencing, target discovery. But it's not just in research, you know, in development as well. We use data science to figure out the risk of the sites, of our clinical sites, to, you know, forecast our clinical supplies, to, you know, applications like, you know, being able to sort of automatically inspect and do QC on our labels, on our clinical supplies. On the COVID vaccine recently, you know, we used deep learning approach to identify potential study discrepancies for a study, but even you know, on the commercial side, you know, we have digital rep advisors essentially that try to optimize our brand strategy and improve the performance of our reps. There's just such a wide range. You know, my scope is quite broad, so I can say I was specifically focusing on an area, but it's just exploding now.
And so, no frustrations?
Frustrations that sometimes we haven't worked out the basics. You know, it's like to me, Teresa, you know, I'm a kind of guy, but just the way my brain works is there are two types of sort of data science applications. There are two ways to leverage your data. One is through experts, data scientists who manage it, you know, run complicated neural networks and draw the conclusions. The other is through mass consumption, visualization, delivering this data in ways that enable every practicing scientist who is not a data scientist, is not an informatician, to understand what it means. The frustration that I've seen, practically in every one of my previous jobs, is that the data is not organized easily in a way that helps consumption, helps its use. So we were reaching for the moon when it comes to the learning aspects of this, the AI aspects of this, and we're still struggling organizing it and curating it and standardizing its ontologies and so on and so forth. This is it's an unsolved problem still.
Yes, okay.
More data, more problems ends up being how it plays out in reality.
And Saul, any insights on, on the things that are the most exciting, and then the other flip coin about the frustrations to make it happen?
Yeah. So there's quite a few frustrations. I'll be really honest. The things that I always tell my team is we take a very product-centric approach into things that we build. So while doing one-off ad hoc analysis or generating insights is key, fundamentally, I'm just interested in building products so that the questions aren't coming to us one by one, but we take a product-centric approach. I have a director of user experience. We do web portals, we do mobile apps, we do a bunch of things. And the intent is to embed as much analytics and data science as possible as a one-stop shop for insights. That's the fun part, is when you actually get to create or combine art and science. The most frustrating part, the thing that I always tell the teams, is not everything we build will be adopted. That's just the nature of our business. Businesses may ask for things and there may be requests, but at the end of the day, the adoption and utilization sometimes has nothing to do with how well you've designed something and what insights you've provided. Sometimes business directions change. Sometimes funding gets cut. Sometimes executive leadership change. Sometimes a perception is created that has nothing to do with what you produced and adoption goes down. So we have to be prepared that 50% of the things that we build will be utilized and 50% won't. And we can't actually predict which ones will and which ones won't. And so that's a frustrating part, because in everything we do, I always say, build what matters, always ask the why. And so there's an intense level of passion that goes into it, and you get really attached to your own program or project. And sometimes it may not go anywhere. And that's really frustrating for the team. I think another element is insights are great, but be careful at the end of the day, because what happens if you generate insights that conflict with the way the business is running their business? We stepped into a situation. So I've actually had a few situations where they've asked us to determine something, assess something, whatever the question may be. And we actually found out that, hey, for our loyalty members that we cherish the most, that are of highest status, that we thought we were developing double-digit margins on, guess what? We're barely making single digits, because when we connected various data sources behind the scenes, we found out that we were comping them so much. And we only knew that because we actually integrated the customer service databases with the revenue management data. And to find out that while we were generating data from them, of course, and it was repeat business, the repeat business was because of the comps that we were providing them, not because they were loyalty members. And so that gets dangerous, because when you're generating insights that fundamentally tells the business that the way you think you've been running the business, there's hesitation on how you've been running the business, it can get you into trouble. And so you have to be very careful with sort of the hype around, we're looking for insights, because if you're not careful of what you come up with and how it's being presented, it could get you in trouble as well. And I think teams need to be more conscientious of that. But the space is really cool in general, because there's such high demand. And I think more than ever, engineers or data scientists are getting more business time than they ever have. And I think that's a lot of fun right now.
Can I expand on this, Teresa, a little bit?
Sure.
Because I now remember my second pet peeve, frustration, because Saul just mentioned, and that's hype. Because this is such a popular subject, it's incredibly hyped. We have, if you can pardon my expression, there's a lot of snake oil salesmen in this business. There's people who, you put AI on top of everything, basically, even simple automation, it's branded as AI. And the poor souls who are not experts in this field, can't tell the difference. You have no idea how many times I've seen AI being multilinear regression.
Wow. Okay. That is so interesting.
That's pretty common at decision trees as well. Just simple, like if then else statements. If then else statements all of a sudden are now classified as AI.
Yep.
That's
Oh
fun.
yeah, classics, business rules that were developed out of classic SQL scripts are now being considered AI. And I'm like, that's
Yeah.
great. It's the next digital transformation. It's RIoT. It's just the next buzzword.
Let's kind of elaborate on this, because there's a question I think that might be related to this, which is that data's input to making decisions, which should leverage the principles and application of decision analysis. Any speaker care to provide feedback on decision analysis quality progress relative to data analytics progress from that perspective? Maybe frame the question is that, are the data analytics feeding into, high level decisions that are, and I think, Sol, you were kind of referring, so go ahead, Kevin.
In the ideal case is that you have this business intelligence suite that's informing these insights. I think Sol gave a great example of like, oh, we got these customers, they've segmented this way. If we double down on that, that's the return on the investment. And that is all nice in theory. If it doesn't match with intuition, then you have to be highly suspect. And then I think the one principle that we've found that is helpful is that you got to keep the KPI, the key performance indicator, you got to keep the insight. You got to watch that forward in time and look and see if your predictive accuracy actually comes true. There's a lot of, this was the insight, this says we should go in this direction, but you got to watch and see that play out, give it an actual proper, the actual prediction engine, and see, does it play out in that sense when you really give it a good validation. And I think it uncovers the overeagerness, the implicit biases that you put into doubling down on what worked for you historically and not really realizing how that may not work for you in the future.
Mm-hmm. Mm-hmm. Okay.
Can I add to this a little bit, Teresa?
Absolutely.
I'm still trying to interpret the question a little bit. It's very, sometimes, AI or machine learning, all of these technologies are yet another means that helps humans make decisions. This reminds me of Marvin Minsky's, credit assignment problem in neural networks, right? You have a overall performance, what neuron, what synaptic connection is most responsible for that kind of performance. It's not easy. It's just yet our decisions, be it on our portfolio, on the fate of our drugs, or whatever the case may be. There's a lot of factors that go into it: intuition, experience, data.
Mm-hmm.
And it's very difficult to attribute. And in fact, there's another aspect to this problem. It's very difficult to attribute a particular technology or to attribute a result, a positive decision or a poor decision, to the use of a model or a particular technology, because it was just yet another factor in this complex, decision-making process. So, and I'm sure that my colleagues here must have seen this, and everybody was listening to us. Show me the ROI of how good, how valuable is this technology, and it's sometimes difficult to put a number on it.
Mm-hmm. Actually, we're really in our last 2 minutes here, and so I did want to give Sol at least one opportunity to also follow up on these questions. That way we've heard from all of you, and then we're going to have to close out for today. So Sol, take it away.
Well, I'm looking at the Q&A. There's actually quite a few questions we can tackle. Is there one that we want to prioritize?
Oh, I was just going to, well, okay, sure. What I was really was following up on is whether you see data analytics as having any new influence on decision-making processes, and that's all really we were going to close out on, since we won't be able to get it.
Yeah. Okay, sure. We'll definitely end with that one. I think this is where EQ kicks in and not IQ. I think because of the way the market is shifting and because of the competitive landscape, businesses are pressured more and more to, if not maintain current market share, or grow market share. And as a result, historically, when they've depended on experience, intuition, pure networks to be able to drive the business decisions, yes, they're depending on data and analytics to inform their decisions. But what I'm discovering is new leaders or seasoned leaders that have used all the trips in the trade, they're actually looking towards data and analytics to solve or answer questions that they have that may or may not be appropriate for the decisions they need to make. Meaning, there's a heavy reliance because there's been such a hype. There's been such an overemphasis on insights and data and analytics and being able to extrapolate a new customer base, being able to understand a new framework or a new market segment to play in, being able to diversify the portfolio. That when I started out in this space, I always say, listen, data doesn't replace common sense and nor does it replace critical thinking. But you got to come to the table informed and using your own experience, your own intuition and the way the business wants to operate, building a more cohesive approach moving forward. But now I think executives are over-indexing and removing the accountability on their end and relying too heavily on data and analytics to tell them the answers, when oftentimes I do think it's a subjective process and not an objective process. And we've got to be very careful when we're presenting or being asked to deliver on insights. So for me, to have the team love the space, I think we have to calibrate expectations that this isn't a silver bullet towards growth. It's one
you so much.
one leg in the stool.
Yeah, I just wanted to say that I think we're going to end here today by just acknowledging that it is another tool, in our arsenal of how we approach, basic science all the way up through, as we discussed in discussion, decision making. That it's part of the landscape. It's clearly going to be part of the landscape now for a long time. Just to sort of answer one last question by Yanis, who was asking, is ML and AI and the hype around it going to suppress all the other advances that have been made in things like mathematical modeling, statistics? And I think the answer is no, right? Which is that it's part of our expanded landscape of being able to do do a lot of interesting science and practical, industry outcomes that were, and how we advance, our industries are all, that's data analytics is really exciting. I hope you got that from today. And that but in the big picture, it's part of the landscape, but it's not going to dominate it in the future. And so anyways, I wanted to thank the panelists, okay, for for all your help today and helping us understanding that landscape. And we'll see you guys next time. So see you soon. Thank you, everyone.
Yeah, thank you. Thank you all for joining today's discussion. Honestly, as a fellow data geek, this was absolutely fascinating, and particularly to hear your different takes on data science in the future. So thank you, Teresa, for facilitating. Thank you, Sol, Dimitris, and Kevin for participating in our panel discussion. Again, look for all of our recordings on Berkeley, on ecosystems.berkeley.edu. We'll be taking a little bit of a summer break from having sessions, but please join us back in the fall for another great series of events. Again, as a reminder, please take a quick second to respond to our post-event survey. And of course, as we finish off things at Berkeley, we always say, go Bears.